All right, hopefully you did well on that quiz. Several students in here made hundreds, so maybe if you're watching, you did as well. Got it? Let's go ahead and take a look at your homework. Book open to page 74, unit number 12. And we were given a few things here. First of all, we were told that KL and AB are parallel. That's significant because if lines are parallel, what kind of angles will be equal to each other, class? Alternate interior angles will be equal. Corresponding angles will be equal. Alternate exterior angles will be equal. And of course, vertical angles are always equal anytime lines intersect. You don't need parallel lines necessarily. Notice I have two transversals. Here's my parallels, KL and AB. What are the two transversals that we have in our picture, Dylan? FD and EC, right here. Okay, those are my two transversals. And we're told that EC is equal to the portion of FD right here between the lines, ED. Now that's significant. Clang! What's got to be true if EC and ED are equal to each other, Lana? If we have two equal segments right here. Well, yeah, CD and ED are equal to each other. That's what we're given. But what's got to be true if those two lines are equal? Brandon? Angle 2, whatever it is, has to equal angle 3, whatever it is. Because if you got in a, notice CDE triangle, if you have equal sides, class, you got opposite angles equal, right? And then we're also told that angle 5 is a 52-degree angle. So I'm going to go and write that in right up front. Hopefully you did as well. From here, it's just a matter of figuring out what's another angle that's equal to this or supplementary to this, or find some relationship. Just get one of the angles knocked out first. And let's start with Noah. Give me any angle that you say. I know how big that one is. Angle 8? All right, how big is angle 8? How'd you figure out that it was 52 degrees? It's the vertical angle of 5. Really no math at all required there. Really didn't even need to know anything about parallel lines to get that one. Give me another angle we already know. Dylan? I'm sorry?
Angle 3.
Angle 3 is what?
52.
Either because it's alternate interior to 8 or because it's corresponding to 5, right? Either way, angle 3's got to be 52 degrees. We'll go back to our claim. If two sides are equal, class, the opposite angles are equal. So if 3 is 52, class, 2's got to be 52 degrees. All right? Give me another angle that we know. Michael?
7.
How big does 7 have to be?
76 degrees.
How did you get that?
A triangle has 180 degrees in it.
Yeah, now this isn't something we've proven yet, but based on past observation, we've noted that the sum of the three angles should be 180. We've already got 104 degrees. That leaves 76 degrees there at the point at angle 7. Give me another angle that we should know. Abby?
1 and 4 would be 128.
Oh, you went and got two of them. Would be how much?
128.
She says both angle 1 and angle 4 are going to be 128 degrees. Abby, how did you get those two?
Because they have 2 of them straight.
Yeah, 1 and 2 are supplementary, 3 and 4 are supplementary. They add up to straight angles. So if they're both 52, they both have a 128 supplementary. The only angle left is angle 6. And Adam? Bless you.
I said,
Yeah.
50. Oh, I was wrong. 30.
How to get angle 6? Josh? What did you have for angle 6 on your paper?
I put 64, but I didn't quite know.
Okay. Brecken?
52.
How'd you get 52?
Angle 8, angle 7, angle 6, add up to a straight angle.
Okay, one way to get it is to say that these three angles, class, add up to a straight angle. And if I've already got 52 here and 76 here, that's 128 degrees. That leaves 52 more degrees. Now there's an easier way without doing any math at all. Dylan?
It's alternate interior.
6 and 2 are alternate interior, aren't they? So they have to be equal. So if 2 is 52, 6 has to be 52. How many had 50? Let's see. If we go in order, 128, 52, 52, 128, 52, 52, 76, and 52 for your angles 1 through 8. You got all of them 8 for 8 correct. All right, those who did it, does it make sense now? Does it make sense now? Go and get another sheet of paper. You can put it in class notes if you wanted to. I would not. But go and get another sheet of paper, and let's draw a couple of parallel lines here. Now let's draw a similar picture here. I'm going to number these angles 1, 2, 3, 4, 5. I'm going to tell you that this angle is 110 degrees. We have an angle 6. I'm going to tell you we have a 40-degree angle also. So there are 6 more angles that I want you to solve for. We'll be given that these two lines are parallel to each other. So if these two lines are parallel, find angles 1 through 6. Again, there's not a set order you have to solve them in. So you don't have to start with 1 and work your way down. Find whatever angle you know. Take about 2 minutes. Hold your breath. We're doing math. Whoa, feels like a long time since we've done any math in this class. So, how many feel like it's good to have numbers again? How many like, actually, I was kind of enjoying not doing any math? All right, Noah. Several people already finished. Still got a little bit more time to work and think. And edit answers as needed. All right, we'll start with Josh. Josh, give me an angle that you already know.
Angle 1.
Okay, how big is angle 1?
110 degrees.
110 degrees. Not because you had to start with 1, but Josh saw that 110 and 1 are corresponding angles. So we got 110 degrees right there. How many also had 110 for your angle 1? Any questions on that? All right, what's another angle that we could solve here, Lana?
Well, 5 is 40.
5 is 40 degrees. All right, how did you know that 5 was 40 degrees?
Because it's, what do you say, corresponds?
They're both between the lines, but they're on alternating sides of that transversal. Alternate interior angles, good. So angle 5 is 40 degrees. How many had 5 as 40 degrees? All right, give me another angle that you already know. Adam?
Let's see. 2.
Okay, how big is 2?
70 degrees.
70 degrees. How did you get 70 degrees for angle 2?
That's supplementary.
Right here, we have a straight angle, so angle 2's got to be 70 because they're supplementary. Good. Give me another angle that we already know. Michael?
angle 3 is also 70 degrees.
Yeah, either because you look here and saw the straight angle, or if you get 70, 3's vertical to it, so 3's got to be 70 degrees. Also, how many also at 3 at 70? How many perfects so far? You got all four of these already? All right, let's see. We're only missing angles 4 and 6. And let's go to Brandon.
Angle 4 is 70 degrees.
How'd you get 70 degrees for angle 4? Okay, so these three angles collectively had to add up to a straight angle, right? And so if they add up to a straight angle, we already had 70 and 40, that's 110. That leaves us with an additional 70 degrees in the middle. So yeah, angle 4 is also 70. That only leaves us angle 6 to solve for. And let's go to Abby for this one. How much? Also 70. How did you get that? Okay, you could either go straight angle here, or you could go alternate interior angles here, or you could go corresponding angles here. A number of directions you could have gone, but we should have gotten 6 to be 70 degrees as well. So not always going to work out this way, but 4 of our 6 angles were 70 degrees, just had a single 110 and a single 40 in addition to the 2 you were given. How many went 6 for 6? You got them all. All right, those who didn't, does it make sense? Which ones did you swap?
Oh, 1 and 2. I put 70 for 1 and 10 for 2.
Okay. So you realize that 1, it corresponds to 110, right? They're both above the respective lines, and they're both to the left side of the transversals. They're in matching positions, which makes them corresponding, and that's where we should have gotten the 110 there. All right. Any other questions, comments? All right. Let me go ahead and give you a handout here. Gavin, or anyone else watching on YouTube, it's going to be handout number 13. Handout number 13. So students in here, it's going to be side 1 of the handout. Okay, so there's 2 sides to it. We're going to look at side 1 of the handout. And pass these back. I'll give 2 more for you and Dylan. So handout 13, we're looking at side 1 of the handout here in the classroom. There's one for you and one for Dylan. And we can use, of course, parallel lines in proofs as well. We've done proofs about parallel lines. We've never used them in a proof. So let's go and take a look at what we've got here. We've got an angle, and this is already on your paper, so you don't need to copy anything right now. It's an angle ABC. And we're told that BD bisects angle ABC. Right there you should be thinking plane. Then we're told that at this random point X, there is a parallel to BC. Okay? And it intersects the bisector at some point called Y. We're trying to prove that the triangle formed by the parallel is an isosceles triangle. All right, so go ahead and get your first statement, first reason written down. And for sake of time, we'll do a little bit of abbreviating here. You wouldn't do that on a graded exam, of course. BD bisects angle ABC, and XY is parallel to BC. All right. We should have a claim statement in here. Go ahead and get your second statement and reason written down. Go ahead and get your second statement and reason written down. And I numbered some angles here, 1, 2, 3, and 4. And those will come in handy for statement number 2. And once you've written statement 2, tell me what you wrote, Brecken.
Angle 1 equals angle 2 because the definition of angle bisector.
How many had exactly what Brecken had? Angle 1 equals angle 2, definition of angle bisector. And it would say angle 1 and angle 2 are equal halves of angle B. If we had another angle that was also bisected, that would be helpful. When there's only one angle bisected, the equal halves doesn't mean as much, but it wouldn't be wrong to say 1 and 2 are equal halves. I just don't need that necessarily. So I've got here angle 1 equals angle 2. Now thinking analytically, we've got our claim statement up here. Let's think analytically. I want to prove the xy is isosceles. What does that mean if the triangle is going to be isosceles, Lana?
At least two sides are equal.
At least two sides equal. Lana, just looking at the picture, I know we don't trust our eyes, which two sides do you think are going to be equal?
Probably BX and BY.
Okay, so these two look equal to you.
Actually, no.
They don't look equal to you,
One
okay?
of them looks higher.
Okay, which ones look equal to you?
Maybe BX and XY.
BX and XY, do these kind of look equal to you? How many think BX and XY kind of look equal? Not that we trust our eyes, but they kind of look equal. All right? So if we wanted, if Lana's right, and she is, these are the two sides that probably are your best shot at being equal, right? If they're going to be equal to each other, what would have to be true to make those two sides in a triangle equal to each other, Noah? If the opposite angles were equal. Don't worry about side 2 right now, Lana. We're focused on, oh, sorry. I'm looking, she's holding her paper up like this, looking at side 1, and I see side 2. I'm like, don't look at side 2. She wasn't, I was. Sorry, my bad. Anyway, so Noah said, if these two lines are going to be equal, we want to get opposite angles equal. Which angles specifically are the opposite angles that we want equal, Josh?
Opposite angles of what?
Okay, focus. I want this triangle to be isosceles. Check. To be isosceles, we need two sides equal, at least. Lana says she thinks these are the two sides we want to be equal. Agreed? If these two sides are going to be equal, Noah said we should get opposite angles equal. Because if opposite angles are equal, them sides going to be equal. Which two angles do we have to get equal? 1 and 3. Does everyone see what Josh is saying? If we can get angle 1 and 3 equal, then the sides are going to be equal. And if the sides are equal, then it's isosceles and we're done with the proof. Y'all see that? Here's the question. How to get 1 and 3 equal? Well, what do we already know about angle 1, class? It's equal to angle 2. If I want angle 1 equal to angle 3, what would be a good in-between kind of statement? Since I know 1 equals 2 and I want 1 equal to 3, what would be a really nice thing if we could say this? Brandon? Does everyone see that if somehow, some way, angle 2 equal to angle 3, then since 1 equals 2, 1 would have to equal 3? Does everyone see that? If only there were a way to get angle 2 equal to angle 3. Well, lo and behold, we have parallel lines. And what kind of angles are 2 and 3, class? Yeah, so I'll say this. Parallel lines isn't a direct clang. Parallel lines is kind of clangy, though, because whenever you see parallel lines, you should think there's some equal angles here. They might be alternate interior, there might be alternate exterior, there might be corresponding. You might want to pick and choose which angles you need. We have picked and chosen that we want angles 2 and 3 equal. Does that make sense? And the reason is there. So number 3, your statement is that angle 2 equals angle 3. Class, say the reason together with me. Actually, I'm going to try more to get the same way it says here. Yeah. Alternate interior angles of parallel lines are equal. I can't just say alternate interior angles are equal, because they're not. If you have parallel lines, alternate interior angles are equal. So alternate interior angles of parallel lines are equal. And so if 1 equals 2 and 2 equals 3, class, then angle 1 equals angle 3. And there's your statement number 4. I believe on the paper I say substitution. Is that right? And there's nothing wrong with that. That's simply taking the angle 3 and going right here and going, the other thing you could have said is quantities equal to the same quantity or equal to each other. But I'm lazy. I'd rather write substitution. Y'all agree? All right? And since 1 and 3 are equal, if in a triangle, 2 angles are equal, class, opposite sides are equal. So we know then that BX equals XY. And again, how will I write out that reason number 5? Dylan? In a triangle, sides opposite equal angles are equal. And because I do indeed have two equal sides, I have, class, an isosceles triangle. Number 6, we will write down, class, that.
Triangle BXY is isosceles.
Good. And reason? Definition of isosceles triangle. And this is kind of an example of how you can use parallel lines in proof to get equal angles. Again, it's not a direct Klang because it's not always the same kind of Klang response. There's a lot of possible Klang responses. But if you see parallel lines in any proof, look for angles to be equal. You'll be able to use that to get strategically certain angles equal to each other. And I just realized, Gavin, I'm sorry, I cut off the back end of the reasons. So in case you didn't get them copied down, there they are. For homework this evening, you're going to do the back side of the same handout. Or if you're Gavin, you're going to do handout 14. Handout 14, it's the back side of the handout we just did, side 2. Don't forget lesson 43 on Friday. You'll have your exam. You'll also turn in your geometry notebooks. Again, you've got your notebook check sheet. Tells you how many points everything is. If you would, make sure that check sheet goes inside the cover of your notebook. So keep that check sheet in there in your notebook. If you need to use some packing tape, some clear packing tape to fix the pocket of the notebook, that would be a great thing to do before you turn it in. I'll take that if you just, tape it really nice with some good strong packing tape, tape it back in place, and it'll be workable, usable again. And that'll be wonderful. And Gavin, I'll give you more specific direction on how you can submit your notebook from Japan to us here in America. All right. And the bell rings, you'll be dismissed. Have a wonderful rest of your day.